Hello everyone and welcome to this video about string theory. Today we will be exploring one of the most fascinating and mind-boggling theories in physics. String theory is a theoretical framework that seeks to unify all four fundamental forces of nature, namely gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. At its core, string theory proposes that the fundamental building blocks of the universe are not particles, as we once thought, but instead, tiny, one-dimensional objects called strings. These strings vibrate at different frequencies, and their vibrations give rise to the different particles and forces we observe in the universe. String theory is important because it offers a potential solution to one of the biggest problems in physics: how to reconcile Einstein's theory of general relativity, which describes the behavior of gravity on a large scale, with quantum mechanics, which describes the behavior of subatomic particles on a small scale. The two theories are incompatible with each other, and physicists have been searching for a theory that can reconcile them for decades. In string theory, particles are not considered as point-like objects, but rather as tiny, vibrating strings. These strings can take on different shapes and sizes, and the different vibrations of the strings correspond to the different properties of the particles they create. For example, a string that vibrates at a certain frequency might create a photon, while a string that vibrates at a different frequency might create an electron. In addition to the strings themselves, string theory also postulates the existence of extra dimensions beyond the 3 dimensions of space and 1 dimension of time that we are familiar with. These extra dimensions are thought to be curled up and compactified, meaning that they are hidden from our view at the scales we can observe. However, they play a crucial role in string theory, and the different shapes and sizes of these extra dimensions affect the behavior of the strings and the particles they create. If string theory is correct, it would have far-reaching implications for our understanding of the universe. For one thing, it would provide a unified description of all the fundamental forces of nature, which is something that physicists have been striving for many years. It would also provide a framework for understanding the behavior of matter and energy at the most fundamental level, which could have practical applications in fields such as materials science and nanotechnology. In conclusion, string theory is a fascinating and complex theoretical framework that seeks to unify our understanding of the fundamental forces of nature. While it remains a highly speculative theory, it has the potential to revolutionize our understanding of the universe and provide answers to some of the most fundamental questions in physics.